Hey everyone, welcome to day six of daily leet code challenge. It's 4:48 a.m. and I've got about 45 minutes to solve this leet code hard question. I'm pretty confident that I won't be able to solve this, but let's try. Given n non-negative integers representing an elevation map where the width of each bar is one. Wait, before that, let me check if I'm live or not. I'm live, but let me check the audio again. Uh, I started streaming about 10 minutes ago, but that in that stream I forgot to configure my audio settings, which led to uh, my stream having no audio. So let me just open it once 10 minutes ago. Yeah, I'm getting audio from my mic over there as well. Yeah, let's get into it. So I'll start the timer now. I have to attempt. I'll try to solve it on my own for about 20 minutes, and if I can't, then I'll look at the solution. Yeah. So we are given an non-negative integers representing an elevation map. So we're given a traps. Right. Okay. So we're given a list. Uh, where the width of each bar is 1, compute how much water it can trap after raining. Okay, so the height is 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. Okay, all right. So yeah, I kind of get it. Output is 6 because 1, 2, 3, 4, 5, 6. Alright, but what if the rainwater? Can the rainwater not be captured over here on the? Yeah, like if rainwater, if rain falls over here, then the rainwater won't be captured and it won't be captured over here as well. So we'll have to find out the uh, area of the water and between uh, these between the first and the second last. No, I mean the second and the second last boxes. Right. That black section is represented by array. Okay, in this case, 6 units of rainwater, blue 6 are being type or height 4230. Uh, let me just write in Excalibur. So we've got this. Uh, let's draw line. So we've got uh, axis or base and in here we have two, the height is 4. So 1, 2, 3, 4. All right, and so we've got 4. So it starts from 0. So this is 0. Uh, and so it's 4, and then 2, 4, 2, 0. Nothing over here. 3, So it goes up to here, 3, and then 2, and now 5. 2. Let me extend it a bit further, and then it's 5. Okay. All right. So now for the rainwater, area after rainwater would be 1, 2, 3, 4, 5. Okay, so it won't be there. 5 and 6. Oh, wait, but it says 9. Okay, 6, 7, 8, 9, 10. I feel like I'm missing something. There's something wrong over here. Uh, so no, so these are the rain boxes. 1, 2, 3, 4, 5, 6, 7, 8. Oh, never mind. It's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So I was counted wrong. This is so these red are the rain boxes, and green is the like the thing that will trap the rainwater. Mm, that's the 0. It's 1, 2, 3, 4, 5, 6. All right. And now, what what are we supposed to do is we'll have to find the number of these containers or the this rainwater are being used. All right. So in this case, 6 units of rainwater is being trapped. So this is the question. It falls under the two. Wait, I forgot the category of this thing. It falls under the two sum something two sliding window. What do you call it? Ah, left pointer and right pointer thing. I forgot what to call it. Uh, I think it was yeah, 2 pointers, 2 pointers. So it's a two-pointer questions. So I've got a little bit of hint on how I have to solve it. Mm, when I like looked at it yesterday, it looked a bit easy, but now I have no idea on what I have to do. The above relation elevation map, black section is represented by array. Uh, wait. It is kind of similar to the question that I did yesterday, right? Uh, so let's just look at these two. So 1 comma 0 comma 2. So 0 is between. So wait, let's look at 2 and this 3. So 1 0 1 is between 2 and 3. Uh, and we've got 3 in here. 1 2 3 4. Okay, it's 4. So what I have to do is, how can I get 4 by using this? So what's the relation between all of these numbers and 4? So one method that I could use is, so what can I do? Let's look at 2 and 3. 3. Okay, there are like 3 things between. So let us suppose, wait, let me turn off the alarm. Uh, yeah. So I've got 101 here. So if the height of the bar is less than, okay, so what's happening is, since the height of the bar between 2 and 3 is uh, less, wait, but before that, so we've got two bars, two big bars, 2 and 3, and since 2 is smaller than 3, the rainwater is only captured till 2, okay, and we're and since between the indexes, the value of the indexes between 2 and 3 is less than 2, uh, 1 less than 2, then it will be captured. So this is 1 less than 2, so it will be captured once, and this is 2 less than 2, so it would be the rainwater that will be captured here is 2, and then the rainwater that will be captured here is 1, because 1 is less than 2 by 1. Okay, okay, yeah, yeah, yeah. All right, I kind of get the algorithm now. So in here, we've got 1 and then 2. So we'll just ignore this first one for now. We've got 1 0 2. The lowest of these two is 1, and since mm, and like since 0 is less than 1 by 1, we've got 1 water source. Yeah, okay. All right. So we've kind of solved on how to, like, how we got the rain, so source blocks till and here. Now let's look at these. 2 is less than 3 by 1, but There is nothing binding free. Oh, yeah. I kind of see what you have to do now. So you have to find the bounding boxes and kind of like just look at the elements between the bounding boxes and do something about it. It is similar to the question yesterday where we had to just find the tallest uh, of the bars. Yeah, like this has kind of same as the question that I did yesterday. Leet code 2 pointers. Yeah, container with most water. So what I did yesterday was I have to find where the most amount of water could be stored. Mm, for that I did something like this. So it's OFN. Then I'll point a breadth, current area, maximum height. If height pointer is less than height, I pointer, I'll pointer by +1 as pointer -1. Okay, so using this, I could find the highest things that could trap rainwater, right? Wait, I think I kind of get now. Uh, how about in here? Let me just start a new test piece, and if I just give this then I should get 0, 1, 2, 3, okay, 3, 4, 5, 6, 7. So like 3 and 7. So 3, 7. It's wait, what? 14? Why is it 14? So container with the most water. Oh, it like uh, uses a formula for storing water, like the length and breadth formula. So 1, 2 times 1, 2, 3, 4. No, 14, the only way to get 14 is by multiplying 7 and 2. Uh, uh, wait a sec. So it's okay, 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 all right. So now get what it's doing. So what it's doing is it's multiplying these two, and since it does not know, but it does know that there are like lines over here. Oh, okay, okay. So in this question, there will be a gap between the lines, but the separators. But in here, there is no gap between the separators. First off, uh, One, two, three, four, five, six, seven. Yeah, exactly seven. One, two, three, four, five, six. One, two. Yeah, it's seven. Uh, okay. So there are like seven spaces. Yeah, I don't think I can use this algorithm without modifying it. Uh, I might have to modify it, or like I actually I don't think it will be useful over here. Mm, So, because so let's look at this question. Support for over here. Yeah, I've got four over here. It's four, and it's like mm, 4, 2. Okay, like so. Let's find the uh, highest two like bars first. So the highest two the separators are 4 and 5. Okay, and now in between I'll have to check by what margin are the bars lower than the lowest between the two highest uh, numbers. So the second highest is 4. So but they can be like side by side by them as well, right? Uh, if they are side by side, then what will happen? Yeah, so if 4 is right over here, then I can't use uh, the bars with the highest and the second highest. I'll have to use the third highest because it will not hold any water. I might not be able to use the third highest if all of them are like right over here. So n equals height dot length. Have not even started to write a single line of code. Mm, Let me think. Hamstrings swimming. Yeah. So that is line. Top of elevation map. Black section is represented by array. 1010 How can I get amount of green water in here? It's not like a programming question, it's more like a math question. So I have to figure out how to get all of these, and then I have to find out, I have to think about how can I code it. Ah, the hard question is are like really different because till now for example, this question, I've known how to solve this because it's like pretty easy. You have to just multiply length by the breadth, the height. Uh, but the hard question, I don't even know what I have to do. Uh, so it's a bit interesting. Hmm. So what separates hard question from medium question is that in medium question you'll know what you have to do or like what formulas you have to use, but in hard question it's a bit tricky. It's more like a math problem, and you have to figure out how to solve that problem, and then only you have to utilize it or like put it into the uh, uh, code. Yeah. Uh, Division. Okay, so I've got a new idea. So you know like how I was trying to find the highest and the second highest bar, right? So now what I have to I'm thinking of is I'll find the highest bar and the second highest bar with some space in the middle. So if we've got something like this, we'll just ignore it. Or like if we got something like this and this, uh, and then this, we'll just ignore it and just find the two bars which are not next to each other. So like there's a space between them. So what I can do is create I've got a bar, right? So here's my bar, and what is this the second highest bar? This is the third highest. And this is the fourth. So I have to find that bar which is not the highest, second highest bar, which is not next to each other. So this will be the second bar. And what if it's like exactly reversed? So what if there is something like this? Hold on. Okay. So if there's something like this, then I'll get uh, the amount of water in here. Wheat, There can also be a condition where like a bar and another bar, which is separated by some space in between. Oh, okay, okay. So wait. I'm thinking about using a dictionary to store the indexes and length of the height of these. And what I can do is, wait, I can't do that. But I could, but no. Yeah, yeah, I was thinking of doing something like uh, z- uh, p- like putting the height. So let's say if this is the height of the towers, we just do something like this, and like this is the height of the zero is one and two and then four. I was kind of thinking of doing something like this, but since it's a dictionary, uh, like this element will not be in the dictionary, it will just be like here. It will just override this thing. We don't, so I'll just have to stick to a list. Yeah, uh, I've only got about 20 minutes now. How long have I been swimming? It's been about 32 minutes, and I still have not gotten a grasp of how should I solve it. Even in the medium questions, like I never had to use a whiteboard to think of the solution, but uh, I'll not look at the solution. I'll just try to figure it out for about next 20 minutes. Mm, and if I can figure it out, then that's great. But I definitely won't be able to put the solution today. Not today, I mean right now. Uh, but I will try to do it at the evening or sometime else. Uh, so how am I supposed to do this? I did understand the entirety of the question correctly, but I can't use hash maps here because they won't be useful. So how about I use what can I use over here? I'll have to use this. So I've got highest and this highest again. Okay, okay. I could do something like this. So I'll just find out the index of the highest. So wait, I could do this in a dictionary. I just have to do something like let's say this is the highest and it's no wait, this is the first thing. Let's it is four and then index is zero and then now we've got this one which is zero and its index is one and this one which index is two and this thing where index is 3, and we've got this entire uh, bar with height 4 again, whose index is 1. So I can do something like this because the value in here in the dictionary can be mutable. So I could do something like this, and I'll check if the highest wait, and just changes it's 1, 2, 3, 4. Okay. So what I could do is I'll take out the highest key from the dictionary, which is 4, and check if the highest key is the index highest key is alone or not. Like highest key is the only bar in the thing or not. So we've got the highest bar and two indexes in after highest bar. So I have to check uh, if uh, uh, there are more than one highest bar, and check if the check if index of the highest of the second highest bar is not if the second index of the hash bar is not equal to the equal to index hash bar is not equals to as in as to the first index of the plus minus 1 1 plus or minus first index of the highest bar. So I have to check if there is only a single bar or there are more than. Alright, so wait. Oh, I didn't know I could do this. Alright. I'm gonna get distracted. Check if there are more than one highest bar. There is more than one highest bar. Check if index of the second index of the highest bar is. Can there be something like uh hmm yeah, I could move forward with this logic, right? And if there is nothing, if two highest bar are separated by some gap, and then yeah, so what I could do is check if the two highest bar are separated by some gap, and then go to the left, check how low is it is. So in this condition, it is lower by 3. So it's 1, 2, 3. So which is like 5 minus 3. So height of this is 5 and height of this is 3. So 5 minus, oh wait, no, height of this is 2. So 5, 2, which is equals 3. So we've got 3 over here. So wait, no, no, no. What we can do is we've got the second highest bar. So we go from left to right. The height of this is 2. So 4 minus 2 equals 2. Hence we got the water blocks, the two water blocks here. And then we got uh, this. So this is 4 minus 0 equals 4. And this is 4 minus 3 equals 1. 4 minus 2 equals 2. Wait a sec. I just thought about something different. Something way easier than doing all of this. So what I could do is wait, let me just turn off the alarm first. I should have turned it off before I started the stream, but yeah, that's fine. Uh, yeah. So guys, I found a way where I could do, but I could find it way easier than doing all of this. So what I thought of is we've got, let's just look at this one. So let me bring it over here, enlarge it. Okay, and so at first we don't have anything here, right? So it's 0. So let's just ignore that. Let's ignore that, and then we've got 1. So we check the right of it. So at the right, so at the right of the 1, we've got 0, which is less than 1. So uh, we've got height, and so we subtract the right element from the left element. So we will get 1 minus 0, which is 1, and yeah, and we got we store 1 and then in a t equals plus equals like this gap equals, yeah, so g, and we go to 2. So this is uh 2, and 2 is greater than 0. 2 is more than 0. So what we can do is we've got this 2. Since 2 is more than 0, we choose this as the wait, no, 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 2 is greater than 1. Could do 2 is wait, everything like falls into like pieces now. What there's nothing else, so ignore that. We've got 1 over here. Let's take the right. So let's put left equals 1. Uh, so we've got left pointer equals left equals 1. Let me just increase this a little bit. So we've got left equals 1, and we go to the and right pointer. So r equals l plus 1, r equals l plus 1, and since r is less than, if r is if height r is less than if r r number and like height of r is less than height of l, then what will happen is then if height of right is less than height of r, then nothing will happen. Nothing else will check else condition later. So nothing will happen. Uh, and then we have left equals left will not change. Uh, we'll have to calculate the units equals units plus units plus equals units plus uh, difference is height of right minus height of left. Okay, so we can height of left minus height of right minus height of difference equals height of left minus height of right minus height of left, where units will be equals to the units plus difference, and like if height of left is more, in this case where we've got 2 over here, what we can do is we've got 2 here, which is greater than height of where height of right is greater than height of left. What we can do is height of height of uh, left equals can do L equals right, and R equals L plus 1. Yeah, we can do this, and we check Uh, you can check if the right thing, right height is less than the left height, which is true. Height is less than the left height. So we'll go over here. Difference is height of right minus height of left minus height of right, which is 1. We'll add, yeah, okay. Now we're getting somewhere. Yeah. So we've got units plus 1. Okay, and we loop again. We've got, okay, and we can do is height of r plus equals 1. So height of, no, not height, it's r plus equals 1. Left does not change, means that right changes, so right is this one, and height of, so r equals height of uh, r that's l equals height of left. Okay, and difference equals height of left, height of r plus 1. So yeah, height of r, right, so height of r is less than height of l, which is true. Difference equals height of left minus height of r, which is 2 minus 0. It's okay, like it's almost solved, and we get units plus equals difference. So units, it, all right, right equal plus equals 1. So right increases by 1. Yeah, that's fine. Okay, so the height of right is less than height of left. Height of right is this is less than. Whoa, I can do this in O of n. Yeah, like now it looks really easy. Uh, it was a good decision to just not try to look at the solution. I'm already out of time, but I'll try look at this for some time again. So height of right is more than height of units plus equals difference. Okay, height of right is less than the left, so it will still increase. And we get to this area where it is not, this is greater than height of left, so left equals right, and we left equals right. And now my algorithm breaks. My algorithm does not work here since height of right is now it stopped working, and yeah, and see enclosed equals enclosed and is enclosed. So for my logic to work, it should be enclosed, but in here it is like not enclosed. So if I try to run a test, it will just look at that. It will just kind of calculate all of these as well, which is I do not want. So, but I'm going in the right direction, and is height of less is enclosed, so this is not enclosed. So if it is not enclosed, then left equals right. Okay, and is this enclosed? Yes, this is enclosed, and it will just get that. Okay. All right, so it kind of work if I use this is enclosed, but I have to like kind of see find out how to do something like this in code. But for now, if I just do it is enclosed, it will work, and I'm not worried about code right now. I'll just try to solve it using like logic and stuff. So let's look at the other thing, this one. So left is 0 and left is 0 and right is al plus 1. So this is like this condition, it works with this because it is really simple. Because uh, this thing will pass these two test cases if I figure out how to put the value of is enclosed. So left equals right is less than this, so it will add, and this. Uh, mm, yeah, how about we'll run on something like uh, this. So we've got this, uh, uh, and this, and then something like this. So the height of right is not less than this. So yeah, nothing will get the water stored over here. It will work for something like this as well. But I have something similar to something like this, and it will try to get this as well. If I, oh yeah. Wait, right, it works. So this is my algorithm. It if I figure out what I have to put over here, how to like check if it is enclosed or not, all of this will work, and it will pass like almost every test cases, even the empty ones. Um, yeah. So I have to find out how to uh, get the value of is enclosed over here. But that's it for today. I don't have a lot of time. I'm like 7 minutes over the limit. I have to close the stream or I'll be late for my classes. So yeah, guys, that was it for today. I found out I found out how to like to uh, I found out like how to kind of solve it. It took me about let's say 21 minutes. Yeah, it was paused in between. It was definitely not 20 minutes. It took me about an hour. Uh, it took me about an hour, but now I know what I have to do. I still have to find out what I have to do for this is enclosed value. But if I am able to get this in is enclosed thing, then it's easy. I re um, yeah, I think I'll not have to. I don't have to look at the solution from YouTube. Uh, it would be very like great if I don't have to look at the solution from YouTube because it's the first question that I've hard question that I'm trying, and if I'm able to solve this hard question, then I'll have the confidence to have even other hard questions. So I'll try my best to not look at the YouTube, and it's only been about an hour, and I've seen other people try to solve it, and even like the professionals, people who work at like the fan companies and stuff, they also take about 1 or 2 hours to solve the hard question. Well, the question that they solve are much harder than this, but yeah, it doesn't matter. I kind of got a rough idea on what I have to do, and uh, now, like later on, like about after my class is finished, I might stream again, uh, or I might not, but I'll try. Do this. I'll try to do this on my own, and I'll keep you guys updated if I'm able to solve this on my own. So yeah, that was it for today, and I'll be ending